Hello, thank you for joining us. I'm here to talk and show you flexibility and affordability of OCI storage services. My name is Narasimha Valiveti. I'm the Vice President of Storage Services at OCI. With me is Max.
Hi, thanks, VNR. My name is Max Verin. I'm the Product Manager and Director of Product Management for the Block Volume Service. I'm in the same storage organization with VNR, overseeing the entire storage portfolio.
Okay. This is a generic safe harbor statement as we are announcing pre-announcing some of the features and futures as well. For the next 40 minutes, what we want to kind of talk and show you is, dependable high performance storage and how one can achieve that high performance and consistent storage with very low and dependable cost. We also want to touch on the DR aspects and then what's coming up in the future. So we offer fast, secure, durable storage options for all your enterprise needs, starting with high performance sub-millisecond latency from block service to highest scale and costly and least costly archive storage. In between, we have fully managed cloud native exabyte scale file systems, as well as elastic unstructured data lakes from ObjectStore. From a storage continuum perspective, right? Storage that can meet all your demands, ranging from performance intensive workloads to exabyte scale data lakes. All of these offerings is what we provide. Secure by default with always on encryption. It includes the OCI identity and access management. Elasticity, use what you need and pay for what you actually use. Enterprise ready, best in industry SLA, so you can confident in trusting enterprise workloads on OCI. Common use cases with block service, you can run the performance or low latency database, SQL, NoSQL workloads, ERP, and with the file and object store, you have other workloads like AI ML workloads and data lakes you can use as well. During the discussion, you will see how block is being used by other file systems as well, and we'll touch on those. But let's deep dive into the performance part. So with that, I'll hand it off to Max to touch on the performance.
Thanks, VNR. So let me talk a bit more about the performance. Just as a starter for this one, we offer the highest performing cloud storage on the market, especially for the block volume service. So I'd like to highlight that a bit more here and go deeper into that discussion. So I highlight as a differentiating features, and the slides that follow pay attention also to the differentiating factors from us, and they're highlighted with the green. So we recently announced ultra high performance block volumes with up to 300,000 IOPS per volume. This is a follow-up to the announcement that we made in 2019, Oracle Open World. At the time, we announced the performance scale, the linear scale performance slider. And at the time, we enabled three specific performance options. It was the lower cost option, and the balanced performance option, and the higher performance option. We started our service with the balanced performance option in the very beginning. It offered 25,000 IOPS. And a 60 IOPS per gigabyte scale factor. We extended with the higher performance option and then introduced this performance slider. We offer a single volume type, Unlike some other cloud providers, you don't see multiple tiers from us. Basically, you allocate the storage that you need, and you can configure for any performance option as you demand anytime you want. So we announced that capability. It was limited to 3 choices at the time. Recently, we extended that scale, the slider with the ultra high performance volumes. We call it the UHP. That offers you up to 300,000 amps per volume based on the VPU setting. And at the same time, we also extended our higher performance offering. Originally, it was supporting 35,000 IOPS maximum per the volume. We increased that number to 50,000 IOPS with no cost to our customers. And actually, you don't have to make any change. If you have a higher performance option volume that you used before, it's going to basically immediately benefit from 50,000 IOPS for that volume. And the idea here is that you can scale anytime you want, and I'll show you a demo in a minute. But in some cases, it's not just a single performance for a single volume, but also I'd like to highlight the aggregate performance on a single compute instance, because you can attach multiple block volumes on a single compute instance. With that, depending on instance shapes, you might actually see upwards of 1 million IOPS per instance with the multiple volumes. We support 32 volume attachments, and each volume can be 32 terabyte in size. So effectively, you can address 1 petabyte of very high performance storage, network storage with our storage offering here. And it has all the advantages that Block provides, basically highly available, durable, linear scaling, and we actually stand by it by a performance SLA also, which is unique from us. Some example scenarios for this dynamic performance slider is to address the needs of, for example, for retail customers. They can adjust the seasonal retail traffic. In some cases, they can actually jump upwards of 200% and plus. So you'll be able to easily meet that demand as you need it, and then you can scale down after that. And also you can handle, for example, demanding CI/CD pipeline builds and deployments as those times demand that extra performance. You can actually set it like that. So let me show you a demo how easy it is actually to make use of this ultra high performance. And I'll show you basically here. So I'll show you a volume which is configured for 25,000 amps, which is our balanced configuration. It is 2 terabyte volume, and it actually gets a target throughput of 480 megabytes per second. And and it's attached to an instance, and instance accesses using a device path. And I'm showing an FIO command, which is industry benchmark tool for measuring the performance of Block devices. So with that tool, I'm running a performance test, and for read and write mix. As you see, the total of read and write operations adds up to 25,000 IOPS. So I'm getting basically what I'm promised to get from our platform for that volume. Now let's change the performance to our highest performance option for the same volume, 120 VPU. That's going to give me 300,000 IOPS. So if you pay attention to the right-hand side here, I'm showing that I have read and write operations immediately changed to about total of 300,000 IOPS, 150,000 read and 150,000 write operations. And there's no impact to my running workload. In this case, it's FIO. So you can treat FIO as your running application. And as you see, I'm actually seeing the performance immediately when I change the performance on the slider. Let's change back to a more reasonable number, let's say 40 VPU. In this case, I see that on the console, I should expect to get 100,000 IOPS, and throughput also scales accordingly. And again, pay attention to the read write on the right-hand side here. For read, I see right now 50,000 IOPS, and for write, I have 50,000, total of 100,000 IOPS. So I'm actually meeting my performance goal very easily without impact to my running application workload, in this case, FIO. And again, the throughput also scales. I'm not showing the throughput exactly here, but let's change this again to a higher performance option, in this case, 20 VPU setting. With this, as I mentioned before, I should see 50,000 IOPS. So again, pay attention to the right-hand side, and I see read of 25,000 and write of 25,000, total of 50,000 IOPS. Okay, so as you see, I can change the performance anytime I want, as frequent as I want, without any impact to my application and running workloads. So with that, let's change back to again, 120 UHP VPUs. In that case, I should still go back to my 300,000 IOPS target. So, as you see, I easily get that without any interruption to my running application workload. So what I like to highlight here is that what I demonstrated, what I just demonstrated is a very powerful and unique feature from our platform. You can view it as an analogous to changing the engine of your car while you are driving. So you can change anywhere from 2-cylinder motorcycle gas engine all the way to the highest performing electric vehicle these days with the longest range battery pack, and anywhere in between, anytime. So, and you use only for what you need and pay for what you use along the way. So this is the beauty of our platform. You don't think about the performance. It comes to you based on the storage that you allocated and your performance targets you should set using our platform performance slider. Now, on the performance side, we are excited to announce a new feature. So it's aligned with our flexible block volume service performance strategy from day one, from the inception of our service. So currently, now you can change the performance, like I just showed you, using the console, API, or CLI, anytime, instantaneous, and as frequent as needed. So you can make use of it right now. So auto-tune, also we enable auto-tune for detached volumes. If the volume is in a detached state, in other words, it's not used, you are planning something, or you are doing some maintenance, or you took the volume offline for some migration or some kind of different maintenance work, you can actually observe and benefit 40% or more cost savings. Because if you set the volume to be auto-tuned when it's detached state, we actually automatically, after some certain time threshold, we automatically change to the lower cost option. So this is integrated with the OCI Cloud Advisor as well. So you can see the volumes that you can take advantage of this feature currently using Cloud Advisor. Now, the next one coming up is, we are excited to announce this. This is another industry first, and also from us, is auto-tune of performance of attached volumes based on throttling that impacts IOPS, throughput, and latency. This is different than the burst performance some cloud providers offer. So there are some options. So the burst performance handling is available. However, this is actually setting a range. In the slide that I show you, you'll be able to set the minimum and maximum ranges. The minimum is the default configuration that your volume is going to operate at. And the max is the maximum performance that you can actually, you allow to reach. Maybe because of some cost reasons, because each performance option actually incurs different cost aspect, right? So based on that, you can set the range, and then we monitor the performance and automatically adjust for you without you being watching it. And you don't need to use APIs for it. You don't use the console. You just enable a single flag, and then the range, and then things happen for you automatically for the performance configuration dynamically. This feature will be applying to both block and boot volumes. And when VNR talk about block storage service, we actually support the boot volumes for all the compute instances as well. So all these features that I announced will be available also for your compute instances. So if they demand more performance, you'll be able to see that automatically coming up. Next, VNR, please give us some more updates about the cost areas here.
All right, that's great, Max. Actually, this is actually very good, right? I don't have to plan for a peak performance requirements months or years in advance based on when the peak performance is needed for a business. It's automatically, as business grows, it's available. We can use it, and even with the workload, if the workload changes, we don't have to keep monitoring it. It's automatically adjusted. So that's great.
That's great. Thanks.
Yeah, let's look at the cost, right? There are three things that I want to cover on the cost, both the block, and then we'll talk about the object and file. So let's go to the block part first, and let's compare block volume cost with OCI versus the other clouds. Let's take a simple example, right? As a 1 terabyte volume, we need about 16K IOPS per volume. let's look at what the annual cost. With the other cloud providers, you would get 8 cents on the storage, some performance cost per IOPS. Your total is going to be about $17.40, right, annually. The same with OCI. The cost, the storage cost is 2.5 cents. And the performance, the VPUs that Max just talked about, 10 VPUs would get you up to 25,000 IOPS per volume. Although you need 16, you're actually with the balanced tier that you applied, the 10 VPUs, you get up to 25. So that's $510 annually. That's about 3x the less cost compared to other cloud providers. Now let's look at a real workload customer environment, right? Let's look at 100 volumes, 101 terabyte volumes. And instead of a 16,000 IOPS, let's say you have some other, high IOPS required apps that requires up to 50K IOPS per volume, right? Let's look at the costing of that with the other cloud providers. As you can see, because of the storage and the performance requirements that are needed, 50K IOPS, the annual cost is going to be 3.6 million, right? Now let's look at what the OCI cost would be. The storage would be at the same cost as we talked about, 2.5 cents. And then if you look at the performance, you went from a 10 VPU to a 20 VPU. That's from a balance to higher performance. You did all this, for example, you don't have to even, you can do this online, right? But look at the overall annual cost, it's a 71,000. So that's almost a 50x lesser cost compared to your other cloud providers. This is what I think differentiates from how we are going to give that low cost and dependable cost as you scale your workloads and go into your environment. Anything you want to add, Max, on the cost part?
Yeah, thanks, Bernard. Very clear example. This is just an example from some of the other cloud providers. So you can actually do the checking yourself. We have a pricing link over here, and you can do different configuration comparisons. However, in general, we are very performance and cost advantageous with respect to anywhere you can find, and also to the on-prem solutions that you might currently have. So thanks for highlighting this, Bernard.
Okay, so let's look at the, so that was a block. Let's look at the object. So we have a new feature, we're calling it auto tiering. This basically, it enables, you can enable auto tiering at a bucket level. What this means is that depending on the access pattern, some of your objects within that object, within that bucket would actually migrate or transition to infrequent access. So based on the access patterns, can be migrated to infrequent access, integrates with the OLM, the Object Lifecycle Management and versioning integration, no additional cost or no operational overhead. When you access the objects from the standard, it will move or it will recall or retrieve it and have it in the standard. This way, you don't, as a user, we don't have to worry about, hey, I manually moved it to infrequent access, and every time I access, I incur the cost, and I had to, if the access pattern changed, I had to go move it back. All that is not needed. If we do see a access being made to that same object multiple times, and we actually tier it to the standard tier and does not have any retrieval fee as part of this. So this will help reduce the storage cost for the customers, right? And then the third is the file. File, we introduced a clones feature. Clones allows you to have a standalone another file system. take a if you have a snapshot, you can actually convert that snapshot to an independent live file system with an immediate access. Instantly, you can get access to the file system. Now, the unique feature is that the clones and the parent file system refers to the same shared data. So no data deduplication or duplication that's happening. In case of block, if you do need that separation or isolation, could use the block volumes, and that would do the the separation. With file, you'll actually have pointing to the same shared data. The use cases used for patching, migration, and several dev and test use cases where you can actually do additional validations on the clone, nothing without changing the original file system, and vice versa. So let's actually quickly jump into a clones demo that will show you. So we'll have a file system. We took some snapshots, and we'll create a clone out of that and show you that. Okay, so we have a file system here. We created 3 separate directories with files in it, and we took snapshots of each after each directory is created, Jan, February, and March. Let's go and create a snapshot, a clone of the file at the Feb. So we have these snapshots at the Feb snapshot. We'll create a clone, right? So we'd call it as a Feb clone 1. Let's create that, and once the clone is created, now we can try and export it and mount this this clone. Okay. All right, so now we have, let's create the directory and mount it. So as we can see that there are files in the clone, as well as we actually create the the snapshots that we had Jan and Feb. Those snapshots are copied as well into the clone. So the clone has that snapshots that we created on the live file system or the original file system. So the Feb and Jan snapshots, you'll see that. Now what we can do is we can actually go and create another directory within the clone, and we'll call that as March, right? So we can call it as March updated within that clone file system. And we created a March updated, and what we'll do is we'll take a snapshot of that file system after we created that March update. We call it March updated snap. Now with the snapshot created, now let's go back and see the contents. So as you can see, we did some operations on the clone file system, the original file system, and all the directories, all that would remain the same. There is not going to be any change. So now you basically have 2 independent file systems that you can work on. Now let's go and you can delete one and the contents on the other will remain the same. So let's go and actually delete for example, the February, right? So with the February deleted, as you can see in the clone, we have January and March, but the original still has the Feb and the files in the original remains the same. Now we are taking a clone of a clone. So the snapshot that we created March, we can actually create a clone of that, right? So now it's actually creating the clone of it, and once it's created, you'll see that turning into green and active. So we created the clone. So as you can see, we had a original, we created a clone, we took a snapshots and so on. For more information on the clones and how we create it and other additional details, you can refer to the documentation. All right, so that concludes my demo. Let's go into the DR part, Max.
Thanks, VNR. It was a great demo. So highlighting the easiness of the file system clones and how I can leverage right now, even for the clone 3. So it was a pretty powerful feature. And next, I'd like to talk about the disaster recovery and what we've been doing in that area. Basically, there are things happen, unexpected happens, even on the cloud platforms. So if that happens, basically, we have some solutions for you. I'd like to highlight them in here. So specifically for the block volume service, we have built-in support for business continuity and disaster recovery. So we have cross-region scheduled backups that have been available for us for quite some time now. You can do this for both volumes and volume groups. So basically backup in a region, and then optionally you can set to copy those across the regions, either manually or through some scheduling. We recently announced enabled asynchronous cross-region replication at the volume level. In addition to the volume backups, now you can actually replicate the volumes themselves across the regions. We initially announced single volume replication for it. Recently, beginning of this year, we announced also volume group replication. That gives you time and crash consistent replication for all the volumes in the group to another region of your choice. So this augments our backup-based DR capability that we already support. With this replication capability, RPO depends on the change rate of your applications, how much data is being changed in the volumes. However, in our observation, it is well within the 30 minutes window. So an RTO of recovery, in other words, of the replicated volumes on the target region is always less than a minute, regardless of the volume size. Whether it's a 32 terabyte volume that you're replicating or 50 gigabyte volume you're replicating, recovery time, access time for the recovered volume is within a minute. So, and again, you pay only for the storage and network transfer costs associated with all these features. There's no feature usage cost, in other words. And the volumes that are replicated on the target regions are kept at the lower cost option for extra cost savings. So let's say you have an ultra high performance volume that you are using, that I demonstrated to you earlier on in Phoenix region, and you replicate that volume to Ashburn region. In that case, your replicated volume will have lower cost setting because it's not directly accessible. So once you activate that volume, at that time, you can set the performance configuration as you demand. As it is actually in the standby replica mode, it will stay at the lower cost option, a lot more cost savings over your original UHP volume on the source region. So with that, let me show you another demo about cross-region asynchronous replication, how that works. So in this demo, I'll show you two regions, Montreal and Toronto. I will have some data that is in the Toronto region, and I want to replicate that data to the Montreal region and access it very fast. So, and see how that works. On the console here, I'm looking at Toronto region, and I have two terminal windows on the right, and one of them Toronto, another one Montreal instance. And on Toronto region, I do an ls block, and then I see all my block devices associated with it. And I replicate that volume to Montreal. I give a name on the Montreal region. And I confirm the network cost associated with replication because I transfer data across the wire. And the cross-region replication is turned on, and I actually go to the demo FS Toronto folder. And I have a file that I have, says hello from Toronto, and go to my Montreal region, and I see my replicated volume here. So replicated volume is available for me to activate. So I click on, basically, in this case, there's no activated volume. I click on activation, give a name for the activated volume. So I'm basically creating a clone out of the replica volume at this time. With that name, it becomes available. And I go to my Montreal instance and I'll check the attached volumes and attach this as a power virtualized volume to a device path that I select. And again, I wait for the attachment to complete. And as you see, it's attached on a specific device that I selected. And on the Montreal instance, I basically take a look at the device that I'm actually replicated and basically mount the file system and then change directory to it and see the content. Demo file came from Toronto automatically. So as you see, within a few seconds, I can actually enable replication for a volume, and I can see the entire content being replicated to another region, and then I can actually start accessing it immediately. Again, this is another powerful feature. What I show you here is for a single volume for simplicity of the demo. However, the same capability is applicable for a volume group as well. So you can set a volume group to be replicated automatically. And upon failover, upon any kind of failure in your target domain, you can activate it. And it's going to give you crash consistent, time consistent recovery on the target region, which you can access immediately and start basically using for your application workload. Next, VNR, please give some information about what's happening in the future. So we have some interesting features coming up in our platform.
Yep, let's talk about that. So one of the things that we are trying to get is the ZFS into the OCI marketplace, as you all know. The things that we are now building is the thing that's coming up is ZFS HA. Now for high availability and from an availability perspective, we wanted to kind of have HA version of the ZFS also in the marketplace. So that's coming up. Now, as a ZFS on OCI actually leverages the underlying OCI block service. So the block service that we talked about from a performance and costing, you will get all of that with the ZFS. It has a multi-protocol support, NFS, SMB, and integrated with the AD integration as well. And feature rich in terms of enterprise customers that are used to using ZFS can now onboard on their applications and use ZFS on OCI. So this is coming up shortly. So let's summarize. I think we kind of touched on 3 demos. We went through the performance slider. We showed the clones and then the cross-region replication. But want to kind of step back and look at, from a storage portfolio, right? Like OCI storage portfolio, what are the common themes and what is it that we are working through, right? I think one of the things is that flexibility and performance. We want to make sure that as applications are onboarded or as you're onboarding your workloads, you have that flexibility. So the block gives you that performance that Max showed up to 300K IOPS with the UHP. And not only that you can go and slide, but it's a workload based. So based on the workload, your performance will vary if you set that the boundaries. So once you set the min and max, within that, depending on the workload, we will ramp up and ramp down as needed. Simplicity and cost, and I walked through the cost analysis with the block. One of the things that we did as part of this is that whenever a volume is detached, we kind of auto-tune so you don't get charged for it. You saw the clones demo that I showed how easy it would be for you to clone and use for your test and dev, for patching or other use cases you want to, so that you can shrink your maintenance window. And then the last one we had is the object store, how you can actually tier automatically. The system can actually, depending on the access pattern, it can tier the objects onto an infrequent access. And as infrequent access tier, so that as you access, it seamlessly gets you the objects as needed. And then the last is the DR and business continuity, right? So how do we, so that's a thing that we are working across the storage portfolio to kind of get that. With the block volumes, whether it's a scheduled or manual. You can do volume or volume group backups within region or cross regions. Similarly, for DR, the volume replication that Max just showed can do at a volume level granularity or a volume group from a consistency perspective. You can do that cross region as well. So those are the features that that we have been working on from a storage portfolio perspective. To the next one. So this is some of the documents, some of the references that you can connect to. The pricing part, we talked about it, block file, object, archive store that we referenced. The documentation is available, and some of the performance stats that things that we talked about is available as well. So I think, Max, we had a few questions and wanted to kind of get your thoughts on it and answer those, right? When you look at the performance, we talked about the performance, and there is something that we called as a VPU, right? And that is unique to OCI. None of the other cloud providers or even the on-prem storage vendors or solutions talk about VPU. What is a VPU, and what's the intent behind it, and how does it help a user to visualize or customer to kind of think about VPUs?
Sure, thanks, VNR. So yeah, we got this question frequently because it's kind of unique for our platform and it's different from others. So it's basically VPU stands for volume performance unit. It is mainly about per gigabyte performance scale factor, and also the maximum volume performance that you can achieve. In the demo that I show you, for example, I went through different VPU settings, and each VPU setting gave me different performance characteristics. So the thing to understand this better, one needs to look into our strategy on the storage a bit more, because we introduced this concept, again, as I mentioned, back in 2019, Oracle Open World. So I'd like to highlight a couple of pillars that are important for us on our storage platform. So one of them is simplicity. It needs to be simple. So for that, we have a single volume type. So you don't have multiple tiers, you just one volume type. You don't even choose a volume type. You just create the storage, right? So, and this has been like that since the inception of our service. So there's one important point to remember. The other one is linearly scaling aspect of our performance. From day one, our goal was to make our service linearly scaled based on the gigabyte allocated. So, and the other one, both IOPS, in other words, IO operations per second, and the throughput linearly scale based on the performance setting that you set on the slider. And the other aspect to remember, for regardless of which performance level you select, we always offer sub-millisecond latency, with the exception of the lower cost option. So balanced and higher up, they all have the same latency numbers. So there's no specialization in terms of latency optimization. And the other advantage of this, you don't have to optimize the performance based on throughput versus IOPS. There's no optimization because you all get the same scale factor. VPU maps those scale factors very nicely throughout the entire platform performance range. The other aspect of it is predictability. When you select a certain VPU number, you have some predictable performance that you're getting. And that performance stays steady. As I show you in the demo, when I set a performance number, it stays rock steady. It doesn't fluctuate at all. It's actually at that number, and which basically allows us to establish a financially backed performance SLA, which is also unique to our cloud platform. Because of these aspects that are actually baked in and in our DNA for the first version of our storage offering, till now, we have all these benefits. And the other aspect that we always strive for is the dynamic nature of this performance change based on customer demand. Okay, so we enable this initially using APIs and CLI and console that I demonstrated to you. Soon it's gonna come up as a dynamic performance based on the throughput and based on the latency aspect of your applications automatically for you. So when you wrap all these things up, VPU provides an umbrella to address performance targets on a gigabyte scale factor. So You can check our performance documentation for more details about each performance level. But one thing to remember is that there are no multiple volume types. There's one volume type. You just create it, and using the slide, you can change it. To give you an idea, and we have 10 VPU increments per gigabyte. So each 10 VPU increment gives you very deterministic performance increment. So for example, IOPS per gigabyte scale changes or adds up. For each 10 VPU increment, you get 15 IOPS per gigabyte, linearly scale factor. And also the maximum IOPS for the volume also changes linearly. For each 10 VPU increment, you expect to see 25,000 maximum volume performance IOPS. So it is very deterministic. So once you get the hang of it, the VPU concept, it actually linearly scales with your storage need, and then you can change it anytime you want. Well, I hope this explains a bit more. And if you have more questions, please don't hesitate to reach out to me or VNR. We can explain more and then talk about it. So thanks. I think, let me see if we get some other questions. VNR, it looks like we got a few questions about the difference between the backups and replication and the best practices and recommendation from OCI for, in general, data protection and recovery. Could you comment on this a bit more?
Sure. This is an interesting topic. And, you know, as we talked about the business continuity and DR, there are two sides of it, right? One is the data protection, which is how do we make sure that you protect your data? How do you make sure that you have enough protection for your workloads or assets, right? So that's where the backups come into picture. Whether you're doing a backup within the region or cross region, that protects you from you know, any kind of tampering of the data that happened, either ransomware or others, right? So that's why the data protection comes in. So that's where you have the backups. Now, the other aspect is the, you know, how do you kind of get the recovery or DR or ability for you to quickly get onto getting your workload up and running in case of a disaster, or in case if your you know, data center lost access to, or you lost access to a data center. That's where the DR comes in, disaster recovery, which is you're replicating the data, your apps, application workload to another site, whether it is, you know, cross town or cross city or cross you know, country. The idea here is that you basically have a certain SLAs that you say, what is it that my recovery point that you want to go back to, right? The point in time. And the other one is how long do you want the recovery time to be, right, for you? So your recovery point objective and RTO, you define that, and that's how you kind of set that DR. So I think it depends on the workloads and the criticality of the applications and how one would set it up. From a best practices, you know, our recommendation is that these data protection and DR are used for two different and different use cases and different purposes and different needs of from a business continuity perspective. So we do recommend that folks actually have a certain policy that they set up for backups, and they take that backup so that they have a point in time that they can go back to. Similarly, we are building the, we announced the block cross-region replication, allows you to kind of do a DR and take advantage of that as well. So the recommendation is to use both where needed.
Thanks, VNR. And I think we got another question well, about the volume groups. I briefly touched up on it as I cover the replication topic, but yeah. Could you explain the volume group a bit more, how it works, advantages? It's a unique feature from OCI, right? So maybe highlight a bit more about that.
So I'll talk about that. So, you know, when you talked about the replicating a volume, so you actually have one volume and your application is using one volume, and that's good. You replicate that and you bring that up. However, In several cases, you won't have just one volume for your application. You would have a varying degree of volumes, because your application depends on those volumes, whether it is a direct dependency or an indirect dependency. In some cases, your logs, your data, your indexes may be on a completely different volumes, and also your boot volume could be. So the idea here is that you have a construct which is basically a grouping construct, where you're saying that, hey, these all volumes, I want it to be consistent, so that when I'm taking them either for a backup or I'm taking them for a replication, I actually have a point in time, whether it is a app consistent point in time, where the application is in some consistent state and you have a point in time of that, or you're taking a crash consistent. You take that group and then you have that point in time available, so that when you're bringing up your application, all of the volumes are with the same point in time, so that you have a consistency from all of the volumes are the same point in time. So that's why we see several of our customers having, whether it's a file systems, whether it is applications, they use multiple volumes, and instead of using at an individual volume granularity, we actually provide that construct of volume group, so that they can group those volumes into that construct and replicate it, so that when we do a snapshot, we're taking a snapshot at that point in time for all the volumes, taking the backup and taking the TR as well, so that they have a point in time. So that's the difference, and that's how we are providing that.
Yeah, thanks, VNR. I remember some of our customers, when they announced the volume replication, they decided to wait a bit more for this cross-region volume group replication because of the advantages that it provides. Thanks for explaining some of the benefits associated with it. So,
right, that kind of concludes all of our questions and so on. So just wanted to say thank you for joining us. Appreciate all your questions and so on. So thank you.
Thank you.